if you had to pick one particular kind of immune system cell that's indispensable, helper T cells are incredible. They essentially activate all the other kinds of immune system cells, or help them to work much more effectively. So without helper T cells doing their job, our immune system is severely compromised. And that's essentially what happens to people that have AIDS. The HIV virus actually invades a type of helper T cell and prevents it from doing its job, and so it can't recruit more B cells, it can't recruit cytotoxic T cells, and as we have fewer helper T cells, the body becomes compromised, and any other infection can become a serious problem and even cause death. That's what people that have AIDS eventually die from, is some other disease, not from the AIDS virus itself. Notice though, with all these memory cells running around, that this is why we have such a rapid response to a second exposure to the same kind of invader. That's why, for example, you may get chickenpox when you're young and never again, because even if you're exposed to the chickenpox virus, we have those memory cells that can quickly mount a defense against it, and before we even realize we're sick, the invader's taken care of and it's gone. That's also the basis for immunization, where for an immunization you take a weakened or damaged pathogen, or sometimes a dead pathogen, but it still has the antigens on its surface, and you inject that into the body, and the body is fooled into thinking it's being invaded. It'll mount a defense against it, an active defense, build all these memory cells. Now, of course, the more serious the invasion, probably the more memory cells are built, which is why for some immunizations it's more effective to introduce a weakened pathogen, like a weakened virus or a damaged virus, instead of a completely destroyed virus. So when producing a vaccine, it's always it's kind of a trade-off between how long-lasting do you want the immune reaction to be versus how dangerous is this pathogen, and do we want to make sure that there's not even a chance of it causing a problem in a person. So say, for example, some very serious viruses like rabies, they make sure they're dead, completely destroyed viruses, rather than just a weakened virus. But something that's not as serious, say for example like chickenpox, is a weakened, or what they call an attenuated virus, and then it causes a more robust reaction. That's why, for example, some shots, some immunizations require booster shots after a few years. For example, tetanus. That's why they don't. Tetanus is a very serious bacterial disease, so they don't want to introduce just weakened tetanus into the body. They'll make sure it's dead. But the immune system may not have those memory cells last forever, so after a few years you may need to get another booster shot of tetanus, so that it kind of boosts up those memory cells again. And that's essentially how the immune system works, kind of in a nutshell, just a condensed version. I hope you learned some of the basics for how our body defends us from all those nasty invaders out there.